So now what is meant by Docker? Docker is a containerization platform. Okay, it is not a container. It is a containerization platform where the Docker is going to hold all the containers. It's an application. Docker is an application. Okay, Docker is an application in which you will have all the containers, in which there will be containers, and these containers will have, and these containers will have, these containers will have applications running. So the main difference between, yesterday we discussed about the virtual machines. So what is the main difference between virtual machines and the containers is, virtual machines will have a kernel. Virtual machines will have an operating system and kernel. Okay. But containers doesn't have the operating system. Containers will not have any operating system. It will have the environment, OS environment, in which you will have binaries and libraries that are required to run the libraries that are required to run the applications. Okay, that are required to run the applications. Okay, that is the main difference between virtual machines and the containers. So in the virtual machines are the logical servers, and when you come to the containers, containers are the logical, what I can say, control groups or else namespaces, or simply I will call them as process, that are running in the Docker engine, which will have their own applications running. And these containers doesn't have any sort of kernel or operating system. No kernel or no operating system is required. We don't need to install the operating systems. Okay, we have to create an environment such that there will be binaries and libraries which will be helpful to work with the containers. Okay, so that's about your containers. Now if you see here, simply, if you think Google Chrome is the Docker engine, Google Chrome is the Docker engine, and whatever the tabs that you are opening here, they are the distinguished tabs. In this tab I can open AWS, in the another tab I can open Azure. Okay, so which means that, so each and every tab will have its own process running in the same manner. So if you are having a Docker application, in the Docker application we are running the containers, and each and every container will have its own application running on it. So it is not same like whatever you are seeing. Okay, the application whichever we are working on the containers is different from the application that is running on the another container, but all the containers will be hosted on the same Docker engine. Now, how to install the Docker in your operating system? So for this, what I will do here is I will log on to my AWS account, and I will create an instance in the AWS account. So already I have an Ubuntu instance running on the AWS account. So it is required to understand AWS. If you are having the prior knowledge about the AWS, that will be good. Why? Because we are working around the AWS only. Or else if you have any virtualization understanding, you can create your own server, like I have created on the virtual machines like this. You can create your own server and you can work around with that server also. If you can see here, this is my what I can say, this is my Ubuntu machine which I am running here. This is what I have created in my local machine. So this operating system or this server is already having the Docker installed inside it. Okay, let me show you that. And if you go back here, so I am having a server. Let us supposing this is the Docker server. This is my Docker server. Right. Okay, let me hold for a second whether it is started or not. Yeah. So if you are having a virtualization like this, or else if you are having a Linux operating system, you can install Docker on the Linux operating system and you can work around with that. Or else if you are having a Windows operating system, nowadays Docker desktop is not properly working with the Windows operating system. I am facing a problem with the Docker desktop. So I'm doing some R&D on this Docker desktop. Actually, previously we used to work with a Docker desktop, but now there is a problem with it. So I'm doing R&D. Once it is done, we can, if you are having a laptop also, in the laptop, if you install the Docker desktop, with the Docker desktop, you can run the Dockerized application. So either you can install on your Windows operating system, or else if you are having your own operating system, Linux operating system, you can go with the Linux operating system. Uh, just give me a second. Okay. So hold on. What is the IP address? 192.168.100.113. So which is my local operating system I'm working with, 192.168.100.113. Okay. Right. Sudo su hyphen. Now look at here. I already installed my Docker ps. I will get the output. So these many number of containers are running, so I can see the output. Or else Docker images. So Docker is running, so that is why I'm getting all these configurations here. So now the point what you need to understand here is, if you are having your own Linux operating system, you can install the Docker in the way that I am showing you. If you are having an Windows operating system, now all Windows, I don't know. So there is a problem with my Windows operating system, or for all the operating system, Docker desktop is not running. There is a problem with that. I am trying to rectify. If possible, I will tell you in the next session. So you can install the Docker desktop and run it. Okay. Or else you can create a Docker server in the AWS account and you can run it. Either the way, it's all your wish. Okay, so I will go with the AWS account and install the Docker in the what I can say, in the AWS machine. Okay, see that there is an error with the Docker desktop I'm facing. So I will try to first of all you have to install the Docker. For installing Docker, you have to work around with all these what I can say commands. So all these commands are available in a single website. What is that website? The website is, if you go here, get.docker.com. In this website, you will have all the privileged whatever the commands that you can see, all will be available over here. So simply you can run this script in your Linux operating system so that Docker will be installed. Right now there is no Docker. If you can see in this system, there is no Docker. But before going into the Docker, let me show you one thing. apt install -y net-tools. Okay, good. So look at here. If I go with this, I am having only two network adapter. For any server that you are getting, there are only two network adapters. One is the what I can say. So there is a server here, and this server is having a physical Ethernet adapter, and there is a loopback adapter which is there for each and every mission. You will have a loopback adapter. So that loopback adapter, whatever you are seeing, it's for the testing purpose. Whatever the loopback adapter that you are seeing, it's for the testing purpose. This loopback adapter will check out the network adapter is working fine or not. And there is one more adapter called as physical adapter. This physical adapter is connected to the network. This physical adapter is connected to the network. Okay. So what happens here, whenever you are working with the network, so the data that is coming from the server will be communicated to the internet and getting back from your network adapter. So whatever the network adapter that you are seeing here, that is the Ethernet 0. This is the network adapter. Okay, so this is the network adapter. Now, when we install the Docker over here, https://get.docker.com and bash. So it will be installing the Docker on your Linux operating system. Previously, if you can see how many network adapters are there, there are only 2 network adapters. Now, after installing Docker, what is going to happen here? So hold on. So these are all the commands which is going to be executed. The same commands you can see in this file also. There are the same commands only. Okay. So the Docker got installed. Here you can see Docker version. So it is 27.21 version, which is a client one, and the server version is 27.21, which got installed. Okay, that's fine. And now if you see here, if config, so we have the third network adapter. Previously, if you see how many network adapters are there, previously there are only 2 network adapters, Ethernet 0 and loopback adapter. Now, if you can see how many network adapters are there, 3 network adapters are there. So one is the Docker 0, Ethernet, and loopback adapter. So here we have installed the Docker. On the top of that, a network adapter is created, and this network adapter is called as a bridge network adapter. And this network adapter is connected to your Ethernet. Okay, so this is how the Docker will be working out. So whatever the containers that are created in your Docker engine, these containers are connected by defaultly to this network adapter. Whatever the new network adapter has been created with the Docker, all the containers are connected to your default bridge network adapter. So if you have any doubt, what you can do here, Docker network ls. If you give this command, here you can see there are 3 adapters. One is a bridge adapter, that is nothing but this one. So you can see the network adapter ID, and the next one is Ethernet 0, so which is nothing but your host adapter, and the next one is loopback adapter, nothing but null or none. So 3 network adapters has been configured in your Docker. In your server. One is the Docker, and the other one is the physical, and the third one is the loopback adapter. So now, as we have discussed how to install the Docker on the Ubuntu machine, let us go for the Docker architecture. What is meant by Docker architecture and how it is going to work out. Okay. Up to now, it is clear how we have installed the Docker. Any questions?
No, sir.
Okay, cool. So now let us go back to the Docker architecture. Now, one thing you need to understand here is whenever we install the Docker, with the Docker CLI will be installed. With the Docker CLI will be installed. What is Docker CLI? Docker CLI is nothing but how user interacts with the Docker. So now whenever we are typing any command, so Docker PS, Docker images, Docker volume ls. What is the mandatory command that we are giving here? Volume ls, Docker network ls. So what is the mandatory command that we are giving here? Everywhere we are providing Docker. So Docker, so which means that we are calling Docker. So here the user will interact with the Docker CLI. To execute any command, the user will interact with the Docker CLI. What are the commands that we are executing here? The command is run command, Docker run, which means to create the container, and then Docker version, Docker images, Docker build, like this. There are so many Docker commands we will be utilizing to interact with the Docker. So when the user provides this command on the terminal, when the user give this commands, there will be a Docker daemon. For example, if you think this is the Docker application, so this Docker commands will go straight forwardly to the Docker daemon. So there will be Docker daemon. So this Docker daemon is main responsible, whole and sole responsible for your entire Docker applications. So this is called as Docker daemon. Okay, so this Docker daemon will be the whole and sole responsible for your entire Docker related application running, containers running, everything will be worked out with the Docker daemon only. So what happens? The command will hit the Docker daemon. So if the Docker daemon is not running, if the Docker daemon is not running, then automatically your Docker will not be functioning. See here, Docker stop, sorry, systemctl stop docker.service systemctl stop docker.socket. So I have stopped this. Now if you give the command docker ps, look at the output what you are getting. Docker version. Okay, you are getting the version from the client, but see about what about the server? The server is not running. So here you can see Docker images. So what is the error you are getting? Cannot connect it to the Docker daemon. So as we have stopped the Docker daemon, so Docker is not properly responding back to the user queries. So which means that Docker daemon is very, very important for running the containers. So if you stop the Docker daemon, automatically the containers will be stopped and automatically your application will not be responding back to the customer. So Docker daemon is responsible. So for example, if you want to create a container, let me restart the Docker over here. Systemctl start docker.socket and docker.service. Now as I have started it, now you can see Docker ps, Docker is running. Now if you want to create a container, so inside the container there will be applications running. Okay, so if you want to create a container, what you have to do? You have to give a command docker run. So this is the command, run command you have to provide. So I have already given here docker run, and you need to provide the name of the container. Name is test container. This is the name of the container, hyphen image, or else have the image name. Why? Because inside the container you need to run the application. So that application requires some binaries and libraries. So inside the image you will have all the libraries and binaries and dependencies, whatever the dependencies that are required to run the application. For example, you have created a Java related application. Is there any Java programmer here? Any Java programmer? Okay, no problem. So now what happens here, if you are running any Java related application, that application will be having certain dependencies. All the dependencies, libraries, binaries will be available in the image. So for now my image is Ubuntu. So this is not an operating system, this is the image. So in the operating system you will have so many number of utilities, but inside the image you don't have any utilities, and we are not installing the operating system inside the container. Try to understand the difference. So if you are going with the virtual machines or else servers, you have to install the operating system, but now with the containers we are not installing any operating system. So we are gathering the images and building the applications. That's it. Ubuntu. Okay, so here we have given docker run hyphen name test container Ubuntu. Now what happens here, whenever we are trying to run that command, so what docker daemon will do here is docker daemon will check in the local registry. So there is a local registry where all the images will be saved. There is a local registry where all the images will be saved. So for example, this is the local registry where I am having the Ubuntu image, or else I can have Nginx image, or else I can have my own customized image. So I will have multiple types of images inside this local registry. Okay, these are all the images. If I don't have the local images in the local registry, then what happens? I will tell you about that. But as of now, what is happening? This is called as local registry. Okay. local image registry. Now from the local image registry, if you are having the images, then Docker daemon will create the container. It is going to create the container. If that image is not there in the local registry, then what happens? Look at here. Whenever we are creating a container with the help of docker run command, here you can see. So what it is saying, docker run hyphen hyphen name test container Ubuntu. I am trying to create a container with the Ubuntu image. Now here you can see unable to find the image Ubuntu latest locally. In your local server, there is no Ubuntu image. So I am pulling from the library. Which library? So if that is, if your image is not found on the local registry, then Docker daemon will go to the Docker hub. So this is the global registry of your entire Docker images. So this is called as Docker hub. So it will go to the Docker hub. Inside the Docker hub, it will try to find out the images. So this is the global registry for all the images, or else Docker registry. Okay. So inside in this registry, you will have multiple number of images, and each image will have different version numbers. Each image which will have different version numbers. So that is called as a repository. So like that, you can find multiple types of registries over here. So these are all the images which are available in the Docker hub. So now what Docker daemon will do? Docker daemon will pull the images from this Docker hub and put in the local registry. So once it doesn't find the image in the local registry, it will go to the Docker hub and pull the images and put in the local registry and creates the container. So that is what happened here also. If you can see docker ps hyphen a. Okay, docker start, we can start the container. What is happening, I will tell you in the next upcoming time, but as of now, docker start, or else if I try to create another container, let me try to create the container docker run hyphen itd hyphen name of the container is test container 2 with the image Ubuntu. Previously, what happened when I try to create the image with Ubuntu, it is saying that unable to find the image Ubuntu latest locally. But now when I am trying to create the container with the Ubuntu, look at that. It is not saying anything. It is just creating the container. Now, what is the difference that you find out from the last case and this scenario? This case or else this scenario, what did you find out the main difference? From the test container one, when I try to create the test container, previously it is saying that the image is not available locally, so I have to get the image. But now whenever I am trying to create the test container 2, now it is saying that simply it is creating the container. What is the difference? As per this Docker architecture, what did you understand about these two scenarios? Can you tell me? Why this time?
Sir, previously image is not created by and
Image is not created or image is not available.
not available. Sorry.
Yeah,
And here
it's not available. Where it is not available?
in a local repository.
In the local repository. How you can say that? Here you can say docker images. If you execute this command, whatever the locally available images will be displayed in front of you. So Ubuntu is available in front of you. So that is the reason. So this is the local image. This is available in the local system. So that's why second time it is not going to the Docker hub. Okay, are you able to understand? So for the second time, it is not going to the Docker hub. Simply, it is collecting the images and it is collecting the image from the local and creating the container. Okay. Understood about this architecture? Any questions here? When you see the architecture, do you have any questions? So these are all the Docker images. Again, don't get confused. What is this hexagon?
Sir, without operating system, how we can run the application by using Docker?
One thing, did I say that there is no operating system, or else did I say that we are not installing the operating system, but we are collecting the binaries and libraries?
Okay.
See, what is the size of the image here?
78 megabytes.
78 MB. Do you get any operating system with 78 MB only?
No,
But here you are having the Ubuntu image which is of 78 MB. Okay, that's fine. Now, did I install any operating system in the container?
no, right now.
No, right? So if I go inside that docker execute -it, the container name is test container 2, and simply I will go with the bash. Look at there, I am inside the container. If you see the command prompt, this one is 172.1600.64. If you see this, what is the ID? 5934. This is the server ID or server name. So here you can find out. So I just logged in. What is the container ID here? 5934. So do you accept that I just logged into the container?
Yes, yes.
Yes. So here I will go with ls-al. Is it giving me the data? What is the command here? List all the folders. It is listing all the folders. Okay. mkdir test ls-al. Is test folder is created? Look at that. Yes or no?
Yeah,
Or
yes,
else let me do one thing. Touch file new, which means that it is going to create a file name called as file new, whether it is created or not. Yes or no?
yes.
So without installing, or else did I install the operating system? I did not install the operating system. Or else is the image is so small that do you really think that all the utilities are available? We cannot say that. That is only 78 MB. So which means that, so it is going to create an environment, and inside the environment what you will have all the binaries. What is this bin means? This bin is nothing but the binaries. Whatever the binaries that you are having in your Linux operating system, the same binaries will be available. The binaries and libraries are available in your image. So with that image, when we create the container, we are using only binaries. We are not using the entire operating system. So if you want to use the entire operating system, you need to install the operating system. You need to have the kernel. So most important is kernel. Without kernel, operating system will, any application won't work. But here there is no kernel, but still the containers are running. How? Are able to understand the point here? So for example, my question is very simple. I purchased a new computer. I will try to rephrase this once. This is my computer. What you will have inside the computer? What you will have inside the computer? General question I'm asking.
RAM, hard disk,
Resources will be there inside the container. Inside the computer. CPU, RAM, and storage. These are the things that will be inside the computer. And to run the computer, what is my requirement? To install any applications, or else to develop any applications, what is my requirement?
operating system.
Obviously operating system. So I am having an OS. So if a user wants to, so what operating system will actually do? So whether operating system will perform all the operations, what is the main functionality of the operating system? It has to, so when the user is asked for something, so I want to open the notepad. I want to open the notepad. So whether the operating system will open the notepad, or whether it will send a signal to the resources such that the resources will understand the requirement and they will open the notepad. What happens in the backend? See, if there is a problem with the RAM, whether your system will work. If there is a problem with the CPU, whether the system will work.
No,
No. So which means that to make functionality, or else to make your system function or work, which is necessary, operating system is necessary. Why? To translate the user requirements to the hardware. But what is more important? The more important one is hardware. Without hardware, what is the use of the operating system? Are you getting the point here? So now, what is the main functionality of the operating system as per your understanding?
It
Whatever the
is a
explanation that we got, what is your understanding towards the operating system?
it is a medium between user and you know, hardware
Okay, so
computer.
it is an interface between the user and the hardware. Okay, this is the first class example, first class definition. Everyone will say that. Now, does really operating system will do that? So whether really operating system will send the requirements to the CPU, RAM, and storage? Have you ever heard the have you ever heard the word called as kernel? What is the functionality of the kernel here? So actually, operating system will gather the requirements from the user and send it to the kernel. So here you will have kernel. What is the main functionality of the kernel? The main functionality of the kernel is to understand the resource performance and understand the user requirements. So user wants to open a very big application for which RAM requirement is very high. So for this, if the application has to run, the RAM requirement is high. So operating system will ask the kernel to open the application. But what kernel will do? Kernel will check with the RAM whether the RAM memory management is there or not, whether the sufficient RAM is there or not. So if the memory management or else if the RAM is not there, then application will not launch. Or else if the RAM is there, then the application will launch. So who will do all these functions? The functions will not be done by your operating system. So the memory management, power management, process management, everything will be done by your kernel. So what operating system will do here is whenever the user requests any data in the user language, that request will be forwarded to the kernel. Now kernel is the main component such that it is going to do all the process management, memory management, storage management, network management. So everything will be done by the kernel only. So if there is no kernel, your operating system will not work. You can search in the Google also what is meant by kernel. It will be giving you a clear-cut picture. So for the containers, whatever the containers that we are creating here, these containers doesn't have any kernel. Then how application will work? So try to understand where we are creating the containers, where we are creating the containers
In Docker,
in Docker. Where is Docker installed? Where is Docker installed?
In the Ubuntu system.
Uber,
In the Ubuntu system, in your operating system only. So now you are having an operating system. Try to understand. Now you are having an operating system, or else first of all, we will come from the core. You are having a server. Right now you are having a server. On the top of the server, what we have installed, we just install the operating system called as Ubuntu. This operating system will be having the kernel also. On the top of that, what I have done, I just install the Docker. On the top of Docker, I am installing the containers. So inside the containers, we can run the applications. That's a secondary thing. So now what happens, it is this Docker is generally like an application itself. Whatever your Chrome or else whatever your normal generalized applications are there, Docker is also an application. So now when this container is running an application, from where it is going to collect the memory and all the things, simple. Just let me give you a small example. You are having Chrome browser or else Internet Explorer browser, any browser you are having. So think Docker is also like a browser. Just for your understanding, I'm saying you. Docker, a normal browser is there. So in the browser, you will open a tab. Okay, you are going to open a tab. So in this tab, what you will do, you will run YouTube. So inside the YouTube, a video will be playing. So to play that video, from where the resources will be taken to play this video, what browser will do? Browser will collect the resources from the hardware itself, right? Yes or no?
yes,
Sound and video, everything. So to process that, it will take the resources from your operating system. In the same manner, here Docker is also an application that is running the process called as container. If this container has to run, from where it has to collect the memory management, power management, or else anything. So that will be interacting with the operating system, and operating system will collect the resources. So try to understand the point here. So here Docker is not a separate virtualization, very big virtualization platform. It is also like a small application. On the top of it, we are running multiple processes. Inside the process, you will have the applications running. But primarily how applications will run by collecting the resources from the physical machine itself. Are you able to understand the point here?
Yes.
Okay, so this is why the applications are having less number of, means it is going to consume less amount of space, and as well as it doesn't have any operating system installed. So it will have only the environment, Ubuntu environment. So in the back end, so it is going to collect your host operating system kernel only. Either it might be, if it is Windows, it is going to collect the kernel from the Windows. If it is Ubuntu, it is going to collect the kernel with the Ubuntu. Now, what is the functionality of the kernel? The functionality of the kernel is to working with the containers. The same thing will be happen in the backend. Now, do you understand the point here? Entire concept,
Yes, sir.
right? So that's about your Docker architecture. In the next session, we will be discussing about the Docker lifecycle, and then we will discuss about the containers. So that's it from my end. If you have any further questions, you can ask me now.